tree diagrams. All right, so we're going to start off in here. And you might remember we were looking at this. All right, and we had some things drawn on here. This is that unit. All right, you don't have to have a copy of it. It's right here from you. You can see it on the screen, so you don't have to worry about it. All right, so we're going to come down here, talk about tree diagrams. Let me stop right there. So one of the things we did was we played the game of Yahtzee. You show me some of your scorecards. Hopefully you did that, and I hope we had a good time playing it. It's kind of an interesting little game. Maybe you've done it before. I'm not exactly sure. Anyhow, there were some interesting scenarios that come about that when you're playing the game, as far as what should I do and how should I play it, right? So, like for example, let's take a look at. I think I can draw on here. Let me see. Oh yeah, here we go. So if we have, say, a couple of, I like that small straight idea. Here's your small straight, and you're trying to get your large straight, right? So the idea then would be, well, I either got to get a 1 or I got to get a 6. All right, so, and I know if I have a regular die, okay, boom, 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 there's my regular die. All right, I can either get a 1 or a 6. That's 2 of the faces on that die. So then we'd have 2. That's our outcomes, right, that we can get over our total outcomes, our sample space of 6. So there's my probability. So I like that 1 out of 3 chances of getting the 1 or the 6 that I need to fulfill for that large straight. All right, so if I have, though, 1, 2, 3, 4, and I got to get a 5, obviously that's just going to be 1 out of 6 to be able to get that one, okay? But what we want to do is take a look at different situations with the game and other probability problems where they're just a tad bit more complicated. How do we figure out what the probabilities are? So one of the things that we use for that in math is called a tree diagram. And a tree diagram can be used to solve probability problems where each branch represents an outcome. And the probability event can be found by taking the product, so we're multiplying the probabilities on each branch. All right, so let me just kind of show you a little bit about how that works. All right, so I'm going to pop back over here for just a second and go into this. All right, and let me go down here. All right, I did this already once, but what happened is that it disappeared on me. So I'm going to try to scooch this down so it's not in your way. All right, so let's take a look at probabilities. Say that I want to have. We're going to start out kind of easy here. We've got 3 dice already rolled up. All right, and what I want to do is get 2 5s. Okay, whether I'm going for my Yahtzee, maybe I'm trying to get a full house, whatever it is, I want to try to get 2 5s. Okay, my other 3 dice, maybe they're all 5s, maybe they're 4s or whatever. Okay, but that's what I want to do. So I'm going to make myself a tree diagram here. And what I'm going to do is I'm going to pick some colors. I'm going to pick this nice looking red, fire engine red, to represent getting a 5. So this is going to be getting a 5. All right. This then would be not getting a 5. I'm going to go with this kind of gray here. So this would be not getting a 5. All right. So this is my tree diagram. Here. I don't know why it's not drawing. Let me try again, because I don't have it clicked. That would be smart. All right, and then the red would be getting a 5. There we go. Okay, let me move this down here to right there. That's getting a 5, and then the gray is not getting a 5. So this is not a 5. So 1, 2, 3, 4, and 6. So there's my first one. So now what I'm going to do is do the exact same thing. So not 5s are going to be down. So that's going to go like this. This is going to go like this. And then when I have a red, All right, that's going to be getting the 5. So that's going to go there, and that's going to go there. So this is getting a 5, getting a 5. Gray is not a 5, not a 5. All right. Not 5, not 5. Okay, so now I'm ready to find this probability. All right, so let's do red. Here we go. So getting that 5 we know is going to be 1 out of 6, right? And 1 out of 6. Right, so that would be 1 out of 6 times a 1 out of 6, which would be a 1 out of 36. Here we got a 1 out of 6 because that's that one, but then it's not a 5, so that would be 5 out of 6. So that would be 5 out of 36, right? Okay, here I got a 5 out of 6 because that's not getting a 5, and then a 1 out of 6 for getting a 5, so that's another 5 out of 36. Remember, you're multiplying these probabilities to get this. So this is 1 out of 6 here, and let me put down the gray so that you know that this is 5 out of 6 here. So I'm going to kind of write it over here, 5 out of 6, 5 out of 6, 5 out of 6. All right? So that's where this 5 out of 6 and this 5 out of 6 comes from. Now I'm going to come down here. Let's do this one. So this is going to be 5 out of 6 times 5 out of 6 because I'm multiplying these two, and that gives me 25 out of 36. All right? So there's how I do a tree diagram. Therefore, the probability of getting my 2 5s is right here. Here's my 2 5s. Okay? Probability of not getting 2 5s, something completely different, that's going to be right here. All right? Now, what does this one represent, though? That's kind of in the middle. All right? So let me move this over a little bit. What does this represent? Right here. Well, that means I got 1 5 and not a 5, right? And 1 not a 5 and a 5. So this would be the probability of getting at least 1 5. So I could at least get a 4 of a kind, right? So that would be 25 out of 36. That is not a very good 2. I'm going to try that again. Much better. All right, 25 out of 36. Okay. Oh, what am I saying? Sorry, my bad. I'm being dumb. So that's going to be 5 out of 36 plus 5 out of 36. There we go. That's more sense. 10 out of 36. All right. There. So 1 out of 36 for 2 5s. 5 out of 36 for 2 not 5. So that would be 1, 2, 3, 4, and 6s. And then if I get at least 1 5, I get a 10 out of 36. All right. That's how that works. Okay. So that's a tree diagram for working with dice. And if we go back to this guy, all right, we'll go back here. Oops, I got to go home first. Open this up. Open it up. We'll see that down here, it's kind of like what I did here, right? Getting 2 5s, 1 6 1 6, 1 6 5 6, 5 6 1 6. You can see that we got the same tree diagram sitting there. All right. Top 2 branches represent rolling the 5. Bottom branches represent not rolling the 5. All right. So I want to do one more tree diagram with you. So let's do one more tree diagram. And this time, let's do it with a little different than rolling dice. How about that, huh? Let's try something different than rolling dice. Let's talk about red lights and green lights. All right, so let's say we have traffic lights. Traffic lights. And I'm just going to have 2 of those darn traffic lights. So whether it's in St. Helens or whether it's in Scappoose or wherever you're driving. All right, we're going to say that to have a red light, oops, I want to go back to, come on, tap on that, give me a red. There we go. So for a red light, we're going to say that that's like 0.3 of a time. So maybe it's 0.3 of a minute, whatever it is. All right, and then we're going to have a green light. Okay, so I'm going to have green. Don't I tap green? There we go. So to have a green light, okay, we're going to have 0.7. So what happened to the yellows? Now we're not going to pay attention to them. All right, we're going to make a tree diagram of this situation. So then I'm going to put my greens on top. So see, here's my greens here. I'm going to draw the green, go like this. Then I'm going to draw the green a little bit more. That's going to be the top. All right, my reds are going to be on the bottom. Okay, so I'm going to go red here on the bottom. Like this, red on the bottom. Okay, then I'm going to extend that red on there. And I got to do one more green. So anytime I have a green, I'm going to get a 0.7. Anytime I get a green, I'm going to get a 0.7. 0.7. Green is on the top. Reds are going to be on the bottom. So I'm going to have 0.3, 0.3, and 0.3. All right. So here we go. Now we're going to use a tree diagram to get some probabilities out here. All right. I'm excited. Here we go. So two greens, G, G. That would be 0.7 times 0.7. All right, or 0.49. There's that one. All right, if I want to do green and red, 0.7 times 0.3, 0.21. All right, here's this one, 0.3. So this is red, green, 0.3 times 0.7, 0.21. And then finally, to get the red, I'm going to just change this to red for this guy. All right, red, 0.3 times 0.3 equals 0.09. Right? So then this tree diagram tells me all the probabilities I can have. Like here's two greens, 0.49. So if I pass through those lights, my chances of getting two green ones, almost 50%. Yeah, that's what we're looking for, right? That's what I want to do to go cruising through. All right, so that would be that one. All right. This would be two greens. If I have a green and a red or a red and a green, at least I get one of them green. That'd be 0.21, right? But remember, if I want the probability of at least one green, then all I got to do is add those up. See, that's what the tree diagram does for me. It allows me to find some different probabilities that might have been a little more harder to do without that, but the tree diagram helps me. And then, of course, here's my probability of my two reds, 0.09. All right. Now, here's the question. Here we go. What if I added these up? 0.49, 0.21, 0.21, and 0.09. What are we going to get there? That's right. We're going to get a 1. All right. We are going to get a 1. Okay, because you're going to get that situation we threw out the yellows. So, that's how you use a tree diagram. Now, I'm going to go back to this thing. All right, you can pause this at any time, too. If you want to look at stuff or whatever, just pause it. Just pause it. All right, so I'm going to go back to this guy here, go home, pause this here. Come on back up. What happened? There we go. All right, so I'm going back to this. Now, we're going to go down to here. All right, this problem, I'm going to make an assignment problem for you. All right, look, it's just one thing. All right. Says, now, you can use a tree diagram to examine another real-world problem, the NCAA March Madness Tournament, which, of course, got canceled this year, but normally goes on. $8.5 billion are bet on that tournament. Huge amounts of money, all right? So with that in mind, every game is very important. Plays can mean thousands of dollars. We're going to watch a video. I'm going to send you a link to the 2005 tournament, all right? And then what I want you to do is watch that. It's real short. You're not going to watch the whole game. We're just going to watch the end of it. And we're going to go through and answer these questions. And you're going to look at a tree diagram. All right. So I'm going to take this part right here. I'm going to put this into a little PDF document. I'm going to attach it to a Google Classroom assignment. All right. And then I'm going to give you the link. All right. I'm going to put the link right in there, and you can watch it and then answer these questions. All right. It's going to have you make a tree diagram. So try it. Just try it. Okay. Do the best you can. All we're doing is this one problem, 1 through G. All right, so I know you can do that. Then we'll talk about it on Thursday. Remember, every other day is all we're doing this stuff, so you won't hear from me till Thursday. All right? Hey, peace out. Have fun. Talk to you Thursday.